All right, so I've covered pretty much everything that I wanted to cover with respect to Python, so I thought that we'd review everything that we've done over the last 2 weeks by pulling out an old assignment here. This is a final exam from 5 years ago or so, and we'll just go ahead and do it. I don't think I've ever done this in Python, so you're going to have to help me because I might be a little bit rusty here. Anyway, and I didn't do it beforehand, so. The theme that year was Scott Frost, I think, had just been hired, maybe it was after his first season. But back in 1997, if you don't know, Scott Frost was our quarterback in 97, the year that we won the national championship. It was a shared national championship with Michigan because this is before the BCS bowl games and the playoff system. And he said, well, if you can look at yourself in the mirror and say that if your job depended on either playing Michigan or Nebraska to keep your job, who would you rather play? Right? So he was advocating for Nebraska to be the sole national championship that year. Anyway, you can ignore the fizz buzz. That was easy points. Basically, there's more background here if you're really interested. Apparently, we won the Orange Bowl against Tennessee 42-17 and finished number one in the coaches poll. But then there was an AP poll where Michigan finished number one. And so what we're going to do is we're going to put this to rest by running some data. All right. So we've provided a dump of data from games that year. Right. The first piece of data is a CSV file with a bunch of teams. And here's what it looks like. The first line tells you how many teams there are. That was just for convenience. We can ignore that because we know how to do this. I think it was for C or something. So that I did that for C because you now need to call malloc to set up enough room to hold 145 teams. And we didn't want you to have to go through it twice to do that, so we just did it on the first line. Anyway, there's a UUID here. That's a universally unique identifier for each team, followed by the team name. So where's Nebraska in this? Fine, Nebraska. There we go. There's Nebraska. At the time, there was something like 145 Division I teams. That may or may not be complete. I'm not sure. But anyway, everything from Miami, Florida, up to Ohio State, Nichols State, et cetera, et cetera. Okay? So that's our first piece of data. There's also data in a games.csv file. This contains all the records of the games for that year. The first line contains an integer of how many records exist in that file, again, for convenience. Then each subsequent line contains the UUID of the away team, followed by their final score, followed by the ID of the home team, followed by their final score. So for example, here's what it looks like over here. There's a game on line 10, right? What team does that represent? Well, what I'd have to do is I'd have to come over here to the team's CSV file and find, that was Missouri, right? That was the away team. They scored 11 points. Who did they play? 41. They scored 41 points. They played Kansas State. So Missouri played Kansas State, and it looks like Kansas State won by a score of 41-11. Right? That's the data that's in both of those files. Now, what we have to do, I gave plenty of starter code. We don't have any starter code. That's why we're going to do it together. Right? What we want to do is produce a ranking of teams based on their win percentage. That is the number of wins divided by the total number of game records that we have. For teams with the same win percentage, we're going to break ties. For example, Michigan and Nebraska had the same win percentage. I think that they were both undefeated. But Nebraska actually scored more points than Michigan did, and more points were scored against Michigan than were scored against Nebraska. That's called a point differential, right? Also, be careful. This data includes non-Division 1A teams like Nichols State, right? I don't know if they still have a football program. They did in 1997. Right? Anyway, so you should only report teams that played 10 or more games, right? It was customary to play 10 or 11 games back then instead of the usual 12 now. And that's why Nebraska went 11-0, Michigan went 11-0. But the point differential is where the distinguishing characteristic comes in. Nebraska should have been the sole number one that year because of the point differential. That's just number of points scored minus the number of points scored against. Okay. There's a whole bunch of starter code that was given. We're not given any starter code here, right? Instead, and then there was a Java version of this too. We need to produce this report from those two files. First step, right? I don't know, touch, Nebraska wins. I don't know, Nebraska's number one. What should we call this? Report, game report. There we go, report.py, all right? Remember, there are only two difficult things in computer science. One is cache invalidation, the other is naming things, right? So where would you start? Immediately load up the data? Let's think first before we load up that data. What do we want to represent? Ultimately, I'm going to produce this report, right? That team is going to have a name, the number of wins, the number of losses, maybe a percentage, but also point differentials for and against. So that's at least 5 things to me: a name, wins, loss, records, points for, points against. I'm seeing 5 things there. Anytime that you find yourself with more than one piece of data, 2, 3 pieces of data, 3, 4, 5 pieces of data, what should you do? Create a class. So let's go ahead and create a class for teams. How do I create a class? Class, yeah, it's not def class, it's just class. It would make more sense if it was def class, but whatever. Class, I'll call it team, okay? Now, I'm going to want an initializer, a constructor for this team. What's the syntax for doing that? Now, here's where def comes in. What was that double underline or dunder method called? Init. There we go. The first argument is always going to be self in Python because you need to scope it to that class. If you don't put a self in there, it's kind of like having a static method in Java. It belongs to the class, but it's not belonging to an instance of the class. So self. What all am I going to want to put in here? Name, team name. Am I going to immediately know what the wins and losses are just from this? No. But what else do I want to know in order to find that team over here? The UUID, right? So maybe I put that first instead. You could call it UUID or you just could call it ID, right? I could initialize, say, wins and right here, right? But it's all going to be 0, right? So let me go ahead and say self.uuid is equal to UUID. Self.name is equal to name. I do want wins, losses, points for, points against. Let's go ahead and just define those. Wins is equal to 0 until we read that other file. Loss. By all rights, we should call it losses, but then nothing would be aligned. It would look a lot less pretty. Points for. Right? Self.points against. Right. And okay, yeah, for and against. Right. Okay. What types are those? I set those to 0. So if I had set them to 0.0, it would have been immediately a floating point number. But are any of these numbers actually going to be floating point numbers? No. So keep them all as integers. Right? Okay. What else would you want eventually? I want a way to print this out, right? So that's going to be our str dunder method, def str under and then self. And then what would that look like if we wanted to make it look like this? Return a formatted string of the team name, self.name, right? We don't need the UUID at that point. And then I'll say that this is a string, and then I'll pad it out with, say, 20, right? That's how we got everything aligned over here, right? If you were doing this in say C or Java, it'd be %20s, but with a formatted string, it looks something like that. Is that right, syntax-wise? How could I test it? Just run it. Game report. There we go. It's correct syntax for now, right? What else do I want? I want the wins. So after that, it'll be self.wins, and then I put a hyphen between, yeah. And actually you can pad that out too, %2d, and then a hyphen, and then loss, and then we have a % sign inside of parentheses there, so parentheses, And this will be, you can put mathematical, I think you could put mathematical expressions in there. What would it be? Wins divided by wins plus loss. And you should put self on all that stuff. Self dot, self dot, self dot. And if you want it formatted out to 3 decimal places, what would it be? 0.3f, I think. Let's see if that's correct syntax as well. So far, so good. Right? So you can put mathematical expressions in there, or you could put that into a variable. Right? It could have been win percentage is equal to this thing right here. And then, oops. And then we can put win percentage in there instead. Arguably, that's a little bit better, even though it's creating a local variable that's not necessary, right? It's a little bit more readable. And frankly, especially with Python, you've already made the choice to use Python, so you're not looking for efficiency to begin with, right? So you might as well go with something that looks and reads better, okay, and is more maintainable. What else do we want? The point difference. All right, so point differential, we'll just put that over here. Point differential is equal to self dot points for minus self dot points against. Right? And notice how I've designed all this stuff without even reading, without even writing a single piece of code to actually open up the file. Right? In computer science 2, you should reframe your mind to start thinking about design questions first. What class do I need, and what functionality would it be? Would I like it to have in order to get this problem solved? Right? I haven't even bothered looking at the files yet, other than to show you what the files look like. Right? I've designed this this object here to take care of all the heavy lifting for me, or most of the heavy lifting for me first. Right? I've designed and implemented it, and then this is point differential right here. There you go. And we can come back and reformat that if we really want to. And by the way, if we're going to use pretty printing, then what would we have to do? Repra, self, and I'll return self dot str. There. Okay. I'm just calling that other function so that they have the same behavior. Instead of copy pasting this, just have a function call that other function. Okay. That's good. Now what we need to do is, well, also Pythonic way of doing things. Does the team class belong in the game report? That's where I put it, but touch team.py. Where should it belong? It should belong in the team module there, right? And what else should I be doing here? To do module documentation, right? And what else should I do? To do class documentation. It doesn't have to be fancy. It represents a team and you're done, right? Okay. All right, and that means I don't need that anymore. It's all over that other class. How do I bring that in though? From team, import team, capital T, right? If you wanted to do, say, import team, what that does is, import team, that imports the entire thing. Right? And every time that I would want something, I'd have to do something like team.team. That's really, really ugly. I think that that's how you would do it, but this is much better. Import team, or from import, sorry. From team, lowercase t, the file, import team. Right? And I can create teams if I want to. Right? We can create a Nebraska team as a testing and see if it works. We've got plenty of... Yeah, we got plenty of time. Nebraska is equal to team. How do I call a constructor? I do not use the new keyword. Instead, I just call it. And what would it be? Nebraska. And what else did I provide it? I forget. UUID. So whatever the UUID is here. 1, 2, 3, 4. Right? 1, 2, 3. Print. NE. All right. Let's see if that works. Ah, darn it. So, yeah. What happened there? Division by 0. Is that going to be an issue if when we actually load up the data? The team wouldn't exist, right? So what you could do is you could go in there and win percentage is equal to that if there are games, else it would be, I don't know, 0. We'll just go with 0 win percentage there. So how do I do that? Well, I could say if self win, like self this plus loss is greater than 0, then I will do what I was going to do. Win percentage is equal to that. Else, and be careful, win percentage is equal to 0. And then I could, that's one way of doing it, right? Remember, yeah, why didn't it like that? I just did Java in the previous class, so I was in Java mode there, right? But also, don't forget your colons, right? There's a colon there, and there's a colon there. Right? This should work now. Yay, they've got a 0 win percentage so far. What's a more Pythonic way of doing this, right? So what I could have done instead is I could have said win percentage, and if you were in Java or C, you could do something like this, is equal to this. If that's greater than 0, then I will take it. Otherwise, or sorry, that's a question mark. Otherwise, I will do 0. Have you seen that in Java and C before? That's called the ternary operator, right? So this is an if. If this is greater than 0, and that's true, then it takes on this value. Otherwise, it takes on this value. That's not in Python. They don't have a ternary operator like this. Instead, this will be this if that is greater than 0, else 0. They use the keywords if else, and then they move things around, right? And that's the more Pythonic way of doing it. Let me make sure that I was right there. I could be wrong. Darn it. That's not what I want anyway. Oh, what is it? If that is greater than 0. There we go. Otherwise it'd still be, yeah, there. That's the more Pythonic way of doing it, if else. Like a ternary operator, but without the ternary operator. All right, I'll leave that in there in case we have trouble, okay? All right, come back over to the, I'm pretty sure that that works. This is just ad hoc testing, by the way. You're doing way more formal testing in your assignments, right? We give you unit tests, and then you have to extend those unit tests, and they've all got to pass. You've been doing it in your labs for the last 2 weeks too, right? That's the better way of doing it. But you still want to do ad hoc testing, make sure that everything actually, is syntactically correct, right? All right, now that I've got that stuff, what do I need to do? Which file should we open up first? The games file or the teams file? The teams, because how do I know what teams those are if other teams have not been loaded yet, right? All right, we might not want to come back there, but whatever. All right, so step 1, open and process teams.csv. How do I open up a file? Open, and then teams.csv for the purposes of reading. How can I'll just get it done in one shot. This is the only way I showed you. There are like a half a dozen other ways of doing it. You can go line by line. You can do it in a buffer. You can do whatever. Just get it done. F dot, read lines, all lowercase. Don't ask me why. Right? It's 2 words. It should be camel cased, but or actually it should be by all means. It should be like that, but it's not. Right? That's what typically happens with programming languages. Somebody just makes it because they wanted to make a programming language without real thought to consistency, and then it catches on, and all the little warts and ugliness that started out with are there for life, right? Anyway, I've got all those lines. If you want to do some more ad hoc testing, we can pretty print them out. pprint lines, just to make sure that it works. And import pprint. Remember, that's pretty printing. Okay, there they all are. Okay. How can I create? I could go ahead and, for line in lines. I want to skip the first one though, so how do I do that? 1:, right? Then I could say, all right, well, split that line. Well, actually, I want to rstrip it first because I don't want that endline character in there. So I could say line.rstrip, right? And I could put that into a variable, A, And then I could say B is equal to A dot. I could tokenize that and split it out based on commas. And then I could create a new a team is equal to team of, what would it be? B sub 0 and B sub 1, right? And then I could add that to a teams dot append T, right? Is this Pythonic at all? No. That would get the job done, right? pprint dot pprint teams. There we go. All the teams are in there now, right? Looks like we needed a little bit more room for Virginia Military Institute. But otherwise, everything is almost aligned, right? Let's go ahead and get rid of that. That was just debugging code. How could I rewrite this as a list comprehension? What would it be? Team of this thing here, right? For B in split. So what would it be? Line dot split or line dot R strip dot split based on commas for line in lines. Something like that. Right. Now, you've done it, I mean, you might not have done a lot of list comprehensions yet, but how many people would feel more comfortable doing this? Because they're coming from C and Java, right? You feel more comfortable doing that. Eventually, though, you get used to list comprehensions and you get comfortable enough with it, then you start preferring this way, as long as it works, by the way. All right, so wrong. What did I do wrong? A 4? I'm not sure. All right, so I did something wrong. That should be there. Well, no, for line and lines, there's, if I split B out into two, this should be two of them, right? Oh, split, no. R strip and then split it based on that. Who was saying that? Yeah, go ahead.
So I had the same problem when reading into stuff with the assignment.
Okay.
And the issue was that it was reading the UUID as a string, and when I was trying to do what you were doing just now, it was going over each individual character in the string of the UUID.
That, I would expect that if you just did it like this. It would end up splitting it based on nothing, or like this, right? What was your solution then? R strip, or strip it out, that'll, for line and lines. Oh, wait.
I just did it as one whole thing, so I did the team of star line dot
That would work, I think. Nope, okay. So go ahead with your solution. You said what?
Star line dot archstrip dot split for line in what yours would be lines.
For, I'm still not getting what you're saying.
So I did, it would be team
Right.
star line dot archstrip dot split at commas for line in line.
Like that?
But move the dot archstrip dot split inside the parentheses for the team.
I'm still not getting it, but like this.
Yeah.
And then get rid of that for line and lines. Okay. Yeah, I'm still not getting it. Anyway, I'm going to put in a to-do, come back and fix this. There we go. Anyway, we've got something that works. It's more traditional. And it's perfectly fine. We're not going to grade based on how Pythonic it is, by the way. If you did something like this is fine too. Right? In fact, this is what I would do initially, and then I would put it into some sort of a list comprehension. Can I get it to work if I do that? Nope. So it would be A at that point. A. Yeah, that works. So maybe we can fix it. I don't want to play with that anymore. We don't have that much time. Anyway, we've got our teams now. Right? By the way, what should I have done up here now that I'm done with it? F.close, just to make sure. I mean, it's read only, so who cares, right? But make sure that you're closing your resources generally. Right? Step 2, read and process the games.csv file, CSV. And to do that, I'm just going to reuse the F, right? And that's going to be open, right? And it's going to be games.csv for the purposes of reading. Right? And once again, I'm going to go ahead and read the lines, right? Reusing that variable as before. It's not like C where you would have to clean up all those strings. There's automated garbage collection just like Java. Once something goes out of scope, it's the Python interpreter's responsibility to clean it up for you, right? So you can go ahead and without thought, without too much thought at least, reassign variables, right? Let's make sure that that's still working. pprint lines, right? There we go. So we are reading those in, right? Let's go ahead and immediately get rid of those end line characters. So lines is equal to line, line.strip, right, for line in lines. Right? I think if I had done it in a series of list comprehensions, it would have worked a little bit better. Let's move that now down here. Right? Oops. Out. I'm pprint lines. Okay. And let's go ahead and get rid of that for now. Right? I'm leaving all the cruft in there for now, but whatever. All right, another for loop here. For line in lines, right? I will strip out the tokens. Tokens is equal to line dot split along commas, right? Let's make sure that that works too. pprint tokens. Maybe there was a problem with what I was doing before. No, it's fine. It's the first one is a UUID. The second one is the score for the home score, or the away score, excuse me. Then the UUID, then the score. So let's go ahead and give those names, right? Once I've tokenized them, the first one, tokens sub 0, that's the away UUID, right? Okay. Then the second one is the away score, and that'll be an integer, tokens sub 1. Oops. Y semicolons, no semicolons. And then the next two are going to be the home team. So home UUID and home score. Okay? All right. Now that I've got those pieces of data, what do I do with them? Let's outline this. Find the home team, or the away team. And once I find the away team, what do? Increment the score and wins or loss. Right? Then find the home team. What do I do here? Increment the score and wins loss. The percentage and the order, we're not ordering them yet, but everything else is already taken care of inside the class. All right? How do I find the away team? Well, I've got a list of teams, right, that I've built up here. I could go through and find, is that the team with this particular UUID? Is that the team with this particular UUID? Is that the team with this particular UUID? I don't like doing that though, right? That's going to be a linear search. I'm going to have to go through every team to find it, and it's way more complex code than it needs to be. Instead, I can come up here and rethink how I'm storing the teams. Right now, I've got them in a list. What other kind of data structures does Python have that I could use to solve to make my life easier? Dictionary, right? Let's go with teams is going to be a dictionary instead. And here we're going to use a dictionary comprehension. What key and what value do you want to map? So you're going to be searching for teams by their UUID, right? So let's go ahead and go with t.uuid. That's going to map to the team for T in teams. I forget, is it a colon? I think it's a colon. Let's find out. Yep, that's good. All right. We're hitting a problem down here because I think that we are not respecting the first line, right? For line, so let's go ahead and get rid of that first line. There we go. There. All right. I don't need the lines anymore. Let me just show you what it looks like now that I've done this map right here. Right? pprint.pprint teams. Right? And there's what the teams look like. There is a UUID that maps to Washington State and their win-loss record, et cetera. The thing on the right-hand side here is a representation. We implemented that Dunder method, repra, right, to call string, and that's why it's being printed out like this. That makes my life a whole lot easier down here. Why? Home team is equal to what? Teams of away, I guess this is the away team, sorry. Let me move that over here and redo it. Away team is equal to teams of away UUID. Right? Now I've got the away team. Home team is equal to teams of home UUID. Right? I could just look it up by its key. That is way easier. All right? Think of ways that you can do that for your first assignment too, by the way. Right? All right, how do I increment the score and the win-loss? So, yeah, go ahead. Yeah, so I could always do the score against and the score for, right? Away team dot, what was it called? Points for and points against. Points for plus equals what? And away team dot points against plus equals what? So the away team, they scored that many points right there. How many points were scored against them? The home team score. Okay. Now, how do I increment their loss or their win? If the away score is greater than the home score, there are no such things as ties back then, right? Then who won? The away team. So away dot wins plus plus. Can I do that? No. Why not? I don't know. All right. Else away dot loss plus equals 1. Okay. What would all this look like for the other team? The home team score would then end up scoring the opposite. Right? And the loss if the away team won versus the wins. Right? Good? Let's see if this still works. I'm going to take this pretty print. Yeah, go ahead. Did I miss something?
You would never add a win to the home team.
Oh, I should have changed this to what? Home team, sorry. Home team and home team. And by the way, I should have done that up there, right? It's the away team, not away. There we go. There and there. All right. Away team. There's the team. There. I made the same mistake right there. What else? Just that. Okay, there we go. All right. How do I know that this is correct? Doing ad hoc testing? Let's search for Nebraska. All right. 11-0, 329. 11-0, 329. I think it worked. Let's search for somebody else. Rutgers. Fine, Rutgers. Didn't win a single one and had a point differential of negative 305. And it looks, yeah. Yeah. How did Indiana do? They won this year, by the way, if you didn't know. Yeah, they were 2-9. What a difference 30 years makes. Right? Okay, actually, it's just 1 year difference that was necessary for them. Why can't it be us? All right, so I've read all the data in. Step 3, order the data by win percentage. Then if that's a tie, we should order it by it's the point differential, point diff. Okay, point differential. All right, how do I sort? Sort teams. Right. Now, is this going to work? Well, first of all, is this going to work as a map? It's going to end up sorting it how? By the keys, which are a bunch of UUIDs. Is that relevant here at all? No. So let's first of all dump it to back to a list that we can actually sort. So team list is equal to a list of, or actually I just need teams.values. That's it, right? And then let's print out the team list. Okay. Sort team, team list.sort, is it? Team list dot sort. But there is a sort method, it's called sorted, and it will take an array, and I believe it'll produce a deep copy of that array, and then sort it, and then give you a copy back. So there is a sorted function for you if you really want. Otherwise, let's just go ahead and sort. All right. Yeah. Oh, actually, I should dump this to a pure list. There we go. And it's still not going to work because how do you order teams? Okay. Now, what you could do is you could provide a key here, right? What would the key be? Or it'd be lambda. Our key is equal to, sorry, lambda. There's my team, T. And by what criteria would you want? T.win percentage first, right? Except that that's not part of the class. Right? We have wins and losses, right? So this would actually require us to break encapsulation a little bit here. What I'd have to do is I'd have to actually compute the wins. So T.wins divided by T.wins plus T.loss. There we go. And then if that's a tie, then I would want what? The point differential. T.points for minus T.points against. Python is not an object-oriented programming language. I would never do something like this in Java, right? I'm breaking encapsulation by pulling those things out. I'm outside of the class right now, right? And so I would, I'm ripping out the guts in order to do logic that involves team. I'm doing team stuff outside of the team class. It belongs in the team class. Python, however, this is how you usually do it. Let's see if it actually works. Probably not. I probably screwed this up somehow. Print, pprint, .pprint, team list. Come on, please. All right, I did screw it up. So, oh, no. Let's see. Okay, yeah. All right, so it is sorting, but what's it sorting by? In ascending order, right? So what would you do to this first one right here to reverse it? You could negate it. Python, there we go. Now, Central Arkansas is down there. 0-1, did they actually only play one game that year? No. That's one of those teams that is not a Division I team that we need to filter. So we're going to come back to that. But otherwise, up at the top here. Let's see. Nebraska and Michigan. Okay. What should I have done to the point differential here as well? Negate that. All right. Yeah, go ahead.
Maybe just negate the entire thing instead of negating the two.
Ooh, can you negate a tuple? Let's find out. Nope. That's a mathematical operation, and a mathematical operation will not operate on a tuple, but the numbers inside the tuple, it will. All right. Okay. So there we go. So where's Nebraska now? There they are, and okay, clear this, run it, find Nebraska. There, now Nebraska is above Michigan, right? We're almost there. What's the problem though? Youngstown State, Southern Utah, Northern Alabama, and Eastern Washington and Cal Poly are all undefeated teams. Congratulations to them, but that's because they only played one D1 game. So after we dump the values, what should we do here? Remove all teams that have less than 10 games, right? Okay, so team list is going to be equal to another list comprehension here. all teams for T in team list if some condition is met. If T dot wins plus T dot loss is greater than or equal to 10. That's going to get rid of all of those minor teams there. And now we've got Rutgers at the bottom, Northern Illinois, 305, 253, negative. That all looks good. All the way up at the top here, 7, 9, 10. There we go. There's Nebraska at the top, Michigan second, as it should be. Right? Now I mentioned, the last thing I'll do here is I mentioned that this is kind of breaking encapsulation. Right? Here's how you can not break encapsulation. I'm going to have to pull something up though first here. Book. Right? There we go. All right, I'm going to go ahead and come over back over here to teams. If this were Java, what you could do is you could make this class comparable. Right? You could take a team and compare it to another team, and it'll return something negative, positive, or 0, depending on the relative ordering of those two teams. Right? It's like a compare to method. Right? I can do the same thing over here in Python, but I can let Python do a lot of the heavy lifting for me. First of all, I'm going to bring in a library to do it for me. Func tools. Right? These are functional programming tools, I believe is what that's for. Import total ordering. Now, you haven't done it in 235 yet, I imagine, but you're eventually going to get to what a total ordering is. It's in contrast to a partial ordering. So integers are a total order. If I gave you two integers, you could say that A comes before B, or they're equal, or B comes after A. What if I gave you two things that were incomparable, though, like some other system of numbers, or usually we use divides by, where this thing and this thing, I have no idea. This one and this one, I can't put them in order because I can't compare these two things. There are algebraic systems like that, and they're called partial orders rather than total orders. We like total orders because there's always an answer. This one comes first, or this one comes first, or they're equal. There's never a question mark. Where does this one go versus this one? I have no idea. That's what a total ordering is. Right? We're going to make this team class into a total order. Total ordering. That syntax there is kind of aspect-oriented programming. What's going to happen is that this library is going to inject some additional code into our class that we don't have to write. It's going to inject a bunch of boilerplate code so that we don't have to worry about typing out a bunch of stuff. You could always do it manually if you wanted to, but I'm bringing in a library to help me do it. All right? Now, there is a contract with this library. It needs to at least have two pieces of information. How do I know if two teams are equal? Right? Self and other. How do I know if this team comes before that team? So I need equals method, and I need a less than method. Self, other. And by the way, you could do a couple of others. I could have done greater than at least, or greater than or equal to. I don't know what it would be, but I only have to do at least two of these things. Let's do less than. Right? Equals and less than. How do I know if two teams are equal? They have the same win percentage, at least as far as this goes, the same win percentage and the same point differential. Right? So return basically this logic over here. Right there. Right? Oops. I come back to my team over here. And not T, but self. Lots of typing, but it's only done once now. Self. Right? Now, that's the first. Actually, I don't need negations here anymore. That's for self. How do I compare it to the other? Right? So I need other, and other. That, other, and other. All I need to do is say, well, if that one is greater than that one, right? Why greater than? Because we want things with higher win percentages first, right? Or sorry, this is equals. This should be equals. There we go. Those two things are equal if they have the same win percentage and the same point differential. What would it look like for less than? Now it's greater. Why didn't I do less than? You could, but then you need to change them around, right? The other needs to come first because it has a higher win percentage, right? Okay. I think. Now I've got myself screwed around here. We're gonna have to, we'll test it, and if not, then I'll just change the sign to greater than, right? All right. Now I can get rid of that. Team list dot sort. By making it into a total order, I don't need that lambda function anymore. The logic for ordering two teams is now where? Where it belongs, in the team class. If you're doing team things, it belongs in the team class. If you're doing person things, it belongs in the person class. This is going to be a design principle that we're going to get into as we get into object-oriented programming. Again, if it still works. Oops. What did I do wrong? Forgot my comma. Hopefully that's the only error. Yay. I get the exact same, I hope. Nebraska's at the top. Yep, Nebraska is still at the top. Right? But this complex logic is all encapsulated inside of this class. By the way, I didn't have to write greater than. I didn't have to write less than or equal to. I didn't have to write greater than or equal to. Why? Because of this library. That's what it's doing for me. It's injecting, it's writing its own boilerplate code and injecting it into my class for me. Right? Java has that too. It's also aspect-oriented programming. We'll get to that. Right? Documentation. Here we go. All right. Any questions on that exercise? Otherwise, we did it. And we did it in only 50 minutes or so with no starter code. Back when we gave this, we gave like all the starter code to load up all the data. So it was halfway done already. No questions? All right. The other drawback, by the way, to a total order is that there can only be one. What if I wanted to order it by team name now instead? Team list dot sort. All right. Now I do need a lambda function. Lambda t dot name. And then let's print this out. What would it look like? Oops. Lambda t, key is equal to. Key is equal to lambda. What would come first now? Arkansas Air Force, looks like. Right. All that's doing is a different ordering, but I can't do that in the total order. A total order, you can only choose one thing, and then you can do other things outside of the class. Right? All right. We might do more Python on Wednesday, or we'll just move on to Java and object-oriented programming.